All right, so we've got a little bit more in 3.3, so we'll call this 3.3 day 2. Here we're starting on slide 9 with our direct variation, kind of graphing them or seeing what we can get from graphs. So this one says a cyclist can ride 3 miles in a quarter of an hour. Assume that the distance biked in miles, y, so y over x, miles over, it varies directly with the time in hours. So it tells us that this situation can be represented by y equals 12x. So they actually gave us the equation. That's fantastic. Graph the equation. How far can the cyclist ride per hour? Well, hopefully you kind of know right here. But let's make a little t-chart. So we have x or hours on the left and y or miles on the right. So I like to do, we don't have negatives in this case. You can't go negative hours. But I'm going to go with 0 hours, 1 hour, and 2 hours. So if we plug those in, after 0 hours, the cyclist has traveled 0 miles. After 1 hour, he's traveled 12 miles. And after 2 hours, 12 times 2, 24 miles. The question asks, how far can the cyclist ride per hour? Well, that would be 12 miles per hour, which is given away here, and we're going to graph it. So time, let's skip a line and just go here. 1, 2, 3, 4, and we can go up by 6s, but 6, 12, 18, 24, 30, 36. So 0, 0 goes to the origin, 1, 12, 2, 24. I could go up, keep going up, 3, 36, 4 up there. Rise over run, rises 12, runs 1 here, nice triangle. All of these things tell me it's 12 miles per hour. Slide 10. The distance d in miles covered by the rabbit in t hours can be represented by this equation. Another fancy way of saying y equals 35x. They just use different letters. The distance covered by a grizzly bear is shown on the graph over here. Which animal is faster? So these two equations are the same, just using different letters. So the rabbit travels 35 miles per hour, given away by that slope. Well, in 1 hour, how far can the grizzly bear go? 30 miles per hour. So we're comparing them here. Which animal is faster? The rabbit, which is probably good because it's going to get eaten. 35 miles per hour is greater than 30 miles per hour. Okay, perfect. Slide 11. County Fair sells 6 oranges for $2. Assume that the cost, so dollars, y over x, that the dollars of oranges varies directly with the number of oranges, so over the number of oranges. This situation can be represented by the equation. Well, let's figure it out. So $2 over 6 oranges simplifies to 1/3. So we could keep that. Let's keep that because otherwise that's y equals 0.3 repeating. So let's go 1/3 x. Graph this equation. What is the cost per orange? So if we want to know what it costs for 1 orange, this would be $1 for 3 oranges. We could simplify that to 0.3 repeating, but talking about money, that's 33 cents per orange. Gonna get a little squishy there. So it's gonna be hard to graph. So we've got y is the number of orange, or y is the cost, so that goes on our y-axis, and x is the number of oranges. So 1 orange, we can make a t-chart here. So x being the number of oranges, y being the dollars. So if I want 0 oranges, I'm going to have $0 to pay. We could also write this as the equation up there, 0, 0. If I want 1, I would get 1/3 of a dollar or 33 cents. That's really hard to graph. So I'm going to pick numbers that are divisible by 3. So if I pick the number 3, if I buy 3 oranges, it would cost me 3 times 1/3 is $1. If I buy 6 oranges, it would cost me $2, which is what they told us. 9 oranges, it would cost me $3. So I can graph that a little bit easier. 0, 0, number of oranges. 3 cost me $1. 6 would cost me 2. 9, 3. So there's our slope of rises 1, runs 3, or 33 cents. All right. This one says graph the following lines. I like to make T-charts so that we are for sure knowing where our ordered pairs are. This 4 should tell us, and this -2 should tell us our slope, though, so hopefully that works out. So if I make a T-chart here, I like to use -1, 0, 1, and 2 when I'm working with just regular graphs that have all 4 quadrants. So if I plug -1 in for x, I would get 4 times -1, which is 4. -4. Whoop. 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8. So it's rising by 4 every time. That's our slope. So -1, -4. 0, 0. 1, 4. 2, 8. Rises 4, runs 1. Showing our little triangle. Rises 4, runs 1. Now this is a negative slope, so that should tell us it's going to go down. But -1 times -2 is positive. 0 times -2 is 0. -2 times 1 is -2. -2 times 2 is -4. So we're decreasing by -2 here every time, which is where that -2 comes from. -1, 2. 0, 0. 1, -2. 2, -4. Should get a ruler out to draw those, but if you look, it falls 2 and runs 1. I should draw it right there. Falls 2, runs 1. There's our slope. Last but not least, push yourself, because no one else is going to do it for you. Have a great day.